The Galactic Engineering Corps prided itself on solving the unsolvable across 400 star systems. Their reputation gleamed brighter than a neutron star's surface. They'd built atmospheric processors on gas giants, constructed space elevators through active volcanoes, and once relocated an entire moon because someone important complained about the tides. When the call came from Threshold 7, a marginal colony world experiencing catastrophic water distribution failures, the Corps dispatched their finest, a committee of 12 species, each more educated than the last, carrying enough advanced degrees to collapse into an academic singularity. Threshold 7 wasn't much to brag about. The planet had water, plenty of it actually, locked up in polar ice caps, and a few massive lakes positioned with all the consideration of a drunk cartographer. The colonists, a mix of 4 species who'd drawn the short straw in the settlement lottery, lived in the habitable band near the equator, where the water decidedly was not. For 3 years, they'd survived on expensive orbital drops and increasingly creative rationing schedules. The situation had gone from inconvenient to desperate to that special kind of crisis where people start eyeing the decorative fountains in government buildings with revolutionary intent. The engineering committee arrived with enough scanning equipment to outfit a small invasion force. They spent 2 weeks analyzing soil composition, atmospheric patterns, geological stability, tectonic movement probability, mineral content, indigenous microbial ecosystems, and probably the colonists' favorite colors for all the good it did. Their conclusion, delivered in a presentation that could have ended wars through sheer tedium, proposed a network of molecular restructuring stations. These magnificent devices would extract moisture from the air, purify it at the atomic level, restructure the molecular bonds for optimal consumption, and distribute it through a pressurized delivery system that required more maintenance than a Vrexian show poodle and cost more than most planetary defense grids. The price tag made the colonial governor's primary and secondary hearts stop simultaneously. Then his tertiary heart joined them in solidarity. His chief financial officer, a pragmatic Torvan with a gift for understatement, described the proposal as financially catastrophic. The engineering committee suggested a payment plan spanning 70 years, which would have been helpful if any of them expected to live that long under the current water rationing. Someone, probably the assistant deputy undersecretary, who was having a particularly bad day and facing termination for budget overruns, suggested they hire a human contractor. The room fell silent. Humans had a reputation in engineering circles, and not the kind you'd put on a resume. They built things that worked, certainly, but with all the elegance of a meteor impact. While other species calculated stress loads to 17 decimal places, humans eyeballed it and added some extra bits they called safety margins, but which looked suspiciously like guesswork. While others designed sleek, efficient systems that interfaced seamlessly with existing infrastructure, humans created bulky contraptions held together with what they called determination, but everyone else recognized as spite and possibly duct tape. The Galactic Engineering Corps prided itself on solving the unsolvable across 400 star systems. Their reputation gleamed brighter than a neutron star's surface. They'd built atmospheric processors on gas giants, constructed space elevators through active volcanoes, and once relocated an entire moon because someone important complained about the tides. When the call came from Threshold 7, a marginal colony world experiencing catastrophic water distribution failures, the Corps dispatched their finest, a committee of 12 species, each more educated than the last, carrying enough advanced degrees to collapse into an academic singularity. Threshold 7 wasn't much to brag about. The planet had water, plenty of it actually, locked up in polar ice caps, and a few massive lakes positioned with all the consideration of a drunk cartographer. The colonists, a mix of 4 species who'd drawn the short straw in the settlement lottery, lived in the habitable band near the equator, where the water decidedly was not. For 3 years they'd survived on expensive orbital drops and increasingly creative rationing schedules. The situation had gone from inconvenient to desperate to that special kind of crisis where people start eyeing the decorative fountains in government buildings with revolutionary intent. The engineering committee arrived with enough scanning equipment to outfit a small invasion force. They spent 2 weeks analyzing soil composition, atmospheric patterns, geological stability, tectonic movement probability, mineral content, indigenous microbial ecosystems, and probably the colonists' favorite colors for all the good it did. Their conclusion, delivered in a presentation that could have ended wars through sheer tedium, proposed a network of molecular restructuring stations. These magnificent devices would extract moisture from the air, purify it at the atomic level, restructure the molecular bonds for optimal consumption, and distribute it through a pressurized delivery system that required more maintenance than a Vrexian show poodle and cost more than most planetary defense grids. The price tag made the colonial governor's primary and secondary hearts stop simultaneously. Then his tertiary heart joined them in solidarity. His chief financial officer, a pragmatic Torvan with a gift for understatement, described the proposal as financially catastrophic. The engineering committee suggested a payment plan spanning 70 years, which would have been helpful if any of them expected to live that long under the current water rationing. Still, humans were cheap, very cheap, suspiciously cheap, the kind of cheap that made you wonder what corners were being cut and whether those corners were structurally important. The human who showed up 3 weeks later arrived in a ship that looked like it had been assembled from spare parts in someone's garage, probably because it had been. The vessel bore the optimistic name Reasonable Decision, which should have been the first warning sign. He disembarked carrying a single duffel bag, wearing clothes that seemed designed for manual labor rather than professional consultation, and sporting an expression of permanent mild amusement that the senior engineers found instantly irritating. He had the look of someone who'd seen this exact scenario play out before and knew exactly how it would end. His name was Marcus Chen, and he toured the colony's water crisis zone with the casual interest of someone browsing a moderately engaging museum exhibit. The alien engineers, led by a Corthian named Veltrak, whose credentials occupied an entire datapad and whose dissertation on fluid dynamics had won the prestigious Sandar Prize, explained their proposed solution with the enthusiasm of parents showing off a gifted child. Chen listened, nodded occasionally, and asked questions that made Veltrak's cranial ridges twitch with suppressed frustration. Questions like, where's the high ground, and does water flow downhill here, or is gravity optional on this planet? And what's the elevation difference between the lakes and the colony, and the particularly baffling you got any wood? Clay? Basic metalworking facilities. When Veltrak finished his presentation, complete with 3-dimensional projections and efficiency charts, Chen stared at the distant lakes, then at the colony, then back at the lakes. He pulled out a device that the engineers initially mistook for advanced surveying equipment, but turned out to be a digital level, the kind an apprentice might use for hanging pictures. He consulted it with the seriousness of someone reading sacred texts. You want water to move from there to here, Chen said, pointing at the lakes and then the colony. Yes, that is the fundamental challenge we have been addressing with considerable theoretical and practical analysis, Veltrak replied with the patience of someone explaining quantum mechanics to a particularly slow rock. Right. I'll make it move, Chen said. The simplicity of this statement felt like a personal insult to everyone present. One of the junior engineers, a Pelthian named Kritz, who'd spent 6 years studying advanced hydraulic systems, made a sound that might have been a laugh or possibly a whimper. The next morning, Chen showed up at the primary lake with equipment that triggered an existential crisis among the engineering committee. Shovels. Actual shovels. Manual digging implements that belonged in a historical archive, not an active construction site. And something he called an excavator, which was essentially a large mechanical shovel on treads. He began digging a ditch from the nearest lake toward the colony, just cutting into the earth like some sort of deranged landscaper. Veltrak nearly suffered a complete systemic failure. "What are you doing?" This was not in any submitted proposal. "Digging a canal," Chen replied, as if this explained everything, which to him it apparently did. "A canal? A ditch in the ground? This is your solution to our water crisis. Water needs to go from point A to point B. I'm building it a road, a wet road, technically called a canal. But the elevation changes, the terrain is uneven, there are obstacles, soil composition varies, you cannot simply dig a trench and expect gravity does the work." Chen interrupted, consulting his level again. "I just point it in the right direction and give it the right slope. 1 meter drop per kilometer traveled. Physics handles the rest. Been working this way for about 10,000 years back home. This is primitive. Barbaric. Completely unsuitable for a modern colony." Chen shrugged and kept digging. Primitives got water, though. The committee convened an emergency meeting to discuss halting this madness. They drafted a formal complaint citing violations of engineering standards, aesthetic concerns, and the general principle that solutions should be at least somewhat impressive. But the colonial governor, staring at the molecular restructuring station's price tag with the hollow eyes of a person contemplating bankruptcy, suggested they let the human continue, just for a few days, just to see what happened. "What was the worst that could happen?" he asked, which is a question that should never be posed in any universe under any circumstances. Chen worked with the focused efficiency of someone who'd done this exact thing 100 times before, probably because he had. The canal grew, cutting through the landscape like a surgical incision. He adjusted angles with his level, built small aqueducts over rough patches using local stone, and lined sections with clay he'd located with the same casual competence. He hired a dozen colonists as laborers, teaching them techniques with names like compacting and grading that sounded suspiciously like barely controlled dirt moving. When the committee pointed out that moving water over a particularly troublesome hill would require pumping stations with power supplies and maintenance schedules, Chen built a water wheel instead. An actual water wheel, wood, nails, and what appeared to be sheer audacity. The engineers gathered around it like xenoarchaeologists, discovering a primitive tool at a dig site. Veltrak's voice carried the hollow tone of someone watching their worldview crumble into dust. "This is a mechanical device from pre-industrial civilizations. This is technology that predates spaceflight by millennia." "Yep," Chen agreed, giving the wheel an affectionate pat that produced a solid thunk. "She'll turn as long as water flows through her. No power source needed. No maintenance beyond greasing the axle every few months." The Persians figured this out around 500 BCE. Still works great. But it is so crude, so inefficient, so aesthetically displeasing. Does it work? The water wheel began turning with a cheerful creaking sound that somehow conveyed more personality than most of the colony's sophisticated equipment. Water flowed up and over the hill through a series of buckets attached to the wheel's rim. On the other side, it rejoined the canal and continued its journey toward the colony. completely indifferent to the engineers' feelings about technological appropriateness. It worked. Chen built 5 more water wheels over the next week, each one tailored to its specific location. The engineering committee stopped offering suggestions and started simply following him around, taking notes like students auditing a class in a subject that shouldn't exist. The humans' approach violated every principle they'd spent decades mastering. He calculated nothing to 17 decimal places. His safety margins consisted of phrases like "should probably hold" and "good enough for government work." When asked about his quality assurance protocols, he knocked on a support beam and said it sounded solid, which apparently passed for rigorous testing in his mind. The terrifying part was that everything worked. The offensive part was that everything worked well. The canals multiplied across the landscape like veins, distributing water with increasing complexity. Chen connected water wheels to grinding stones that processed grain for the colony's food production. He rigged others to pump systems that filled storage tanks on elevated platforms, creating water pressure through gravity rather than powered pumps. One particularly ambitious wheel powered a sawmill that produced lumber for more construction, which he used to build more water wheels, creating a self-perpetuating cycle of primitive industry. The colony's infrastructure began expanding around his water system, like a city organizing itself around a river. Markets appeared near the canals, workshops clustered around the water wheels. Colonists who'd been rationing every drop suddenly had enough water to consider luxuries like gardens and fountains, which, a few engineers realized with creeping horror, was exactly what ancient human civilizations had done thousands of years ago. Then Chen did something that elevated the situation from controversial to completely unhinged. He expanded the project without asking permission. The main canal, which had reached the colony and successfully provided water to every district, suddenly sprouted branches like a tree growing new limbs. Chen dammed a section, creating an artificial reservoir. The water wheels grew larger, their mechanical connections more elaborate, their purposes more ambitious. Veltrac found him installing copper wire and complex mechanical assemblies. "What is this?" "This was not in the contract." "Generators," Chen replied, as casually as someone mentioning they were making lunch. "Generators for what purpose?" "We have fusion power for the colony." "Had fusion power? I checked your fuel reserves. You've got maybe 6 months left, and resupply isn't cheap. Meanwhile, I've got all this mechanical energy from the wheels. Seems wasteful not to convert it to electricity. You are generating power from water flow, from these primitive devices. Hydroelectric generation. Pretty standard stuff. Did it on Earth for centuries before we figured out fusion. Three Gorges Dam produced 22,500 megawatts back in the day. I'm not building anything that ambitious, but this should cover your colony's needs." The committee held another emergency meeting, which had become a daily tradition. Chen was constructing a power plant, an actual power generation facility, using nothing but flowing water and mechanical ingenuity that belonged in a museum. The colonial governor, who'd been receiving daily reports of increasing absurdity, accompanied by decreasing costs, approved the expansion. Why stop now? The human was clearly operating in a state beyond conventional reason, and somehow that state included solving all their problems. Chen built a dam proper, not the temporary diversion, but an engineered structure with spillways, control gates, and a design that incorporated principles he explained came from beaver observation. Behind it a lake formed, creating a reservoir that regulated water flow and provided recreation opportunities the colonists hadn't enjoyed in years. Beneath it, water roared through channels he'd carved into bedrock, spinning turbines he'd fabricated from local materials, and parts salvaged from broken equipment that had been gathering dust in storage. The generators hummed to life with a sound that made the colony's chief engineer weep openly. Suddenly the colony had power. Lots of power, more power than the molecular restructuring stations would have provided, delivered more reliably, at a fraction of the cost, and without requiring a single shipment of replacement parts. The engineering committee watched the hydroelectric facility operate with the stunned silence of people reassessing their entire careers. Veltrak ran efficiency calculations 3 times, certain he'd made an error. He had not. The humans' primitive system was outperforming their advanced technology in every measurable metric except sophistication, and sophistication, they were learning, did not pay the bills or keep the lights on. How much did this cost? The colonial governor asked, afraid of the answer, but needing to know. Chen provided an itemized list written on actual paper, which seemed appropriate given the circumstances. Materials, mostly local stone, clay, timber, and metal. Labor, just him and a crew of colonists he'd trained in ancient construction techniques. Equipment rental for the excavator, and some welding gear. The total came to roughly 1/50th of the molecular restructuring station proposal. 1/50th. The governor sat down before his hearts decided to take another synchronized vacation. His financial officer began laughing, a sound that bordered on hysteria but carried undertones of profound relief. Chen wiped his hands on his work pants, surveyed his creation with the satisfaction of a job completed, and began packing his tools. Water flows from the lakes through the canals into the colony. Waterwheels provide mechanical power for various operations like milling and pumping. The dam and turbines generate electricity for everything else. Systems pretty much maintenance-free, just clear debris from the channels monthly and grease the wheel axles quarterly. Any colonist can do it. I've written up instructions. But this is so simple, one of the younger engineers protested, gesturing at the canal system like it had personally offended him. We are advanced civilizations with technology that can reshape reality itself, that can manipulate quantum states and fold space. And you solve our crisis with dirt and wood. Sure, Chen agreed, loading the last of his equipment. But why fight physics when you can ride it? Gravity's free. Water flows downhill naturally whether you want it to or not. Wheels turn when water pushes them because that's what wheels do. I just arranged things so nature does what it already wanted to do. Everything else is just fighting the universe for no good reason. This is barbaric, Veltrak said, though his voice carried less conviction than before. He'd spent the morning running simulations, and they all confirmed the same disturbing truth. The primitive system was superior. This is paid for, the governor countered, staring at the budget reconciliation with the expression of someone who just discovered money could be saved rather than exclusively spent. This is functional. This is ours without debt. Call it whatever you want. Word spread through the Galactic Engineering Corps with the speed of scandal, which in a civilization with faster-than-light communication meant instantaneously and with considerable embellishment. Other colonies, struggling with similar infrastructure challenges and drowning in debt from sophisticated solutions, began requesting proposals. Specifically, they requested the primitive human method, which became the phrase's official designation and eventual trademark. The Corps fractured into factions. Traditionalists insisted on maintaining sophisticated solutions, arguing that reputation and advancement required complexity. Pragmatists pointed at cost savings and asked why they'd been overcomplicating everything for centuries when simpler options existed. A third faction, the reconciliationists, suggested perhaps both approaches had merit depending on circumstances, which satisfied no one but at least sounded diplomatic. One particularly heated debate at the annual engineering symposium devolved into a Vrexian researcher demonstrating that a simple lever could move more mass than a gravitic manipulation field while using zero power, and didn't that say something profound about their approach to problem solving? It said several things, actually, none of which the advanced civilizations wanted to hear. Primarily, it said they'd become so enamored with sophisticated solutions that they'd forgotten to ask whether sophistication was necessary. They'd been building fusion reactors to power light bulbs, using quantum computers to balance checkbooks, and employing reality-altering technology to accomplish tasks that rocks and sticks could handle. Chen, meanwhile, had already departed Threshold 7, moving to his next contract. The job posting mentioned something about atmospheric circulation problems on a colony experiencing stagnant air and heat buildup. He'd packed his excavator, his shovels, and what appeared to be several very large fans. The contracting agent had asked if he needed technical specifications for the planet's atmospheric composition, pressure gradients, and thermal dynamics. Chen had replied that he mostly just needed to know which way the wind blew and whether they had any tall structures he could work with. The agent's response is not recorded, but reportedly involved several moments of silence followed by hesitant contract approval. Back on Threshold 7, the canals flowed with the patient consistency of geological features, which given enough time they would become. The waterwheels turned day and night, their creaking rhythm becoming part of the colony's ambient soundscape. The power plant hummed with the satisfaction of a system working exactly as designed, generating electricity that cost nothing but occasional maintenance. The colonists, who'd expected to spend decades paying off water infrastructure debt, instead found themselves with surplus power to sell to passing ships and enough water security to plan expansion. The colonial governor commissioned a statue of Chen, which the human had politely declined to attend the unveiling of, claiming he had ditches to dig elsewhere and probably meaning it literally. The statue depicted him holding a shovel, which the Galactic Engineering Corps initially protested as undignified and unsuitable for a monument to engineering achievement. Then they saw the inscription, "He made water flow uphill, using only downhill." The protest died in committee. Veltrac visited the hydroelectric facility regularly, ostensibly to monitor its performance, but actually to stare at it with the bewildered fascination of someone whose entire education had been rendered simultaneously valid and completely beside the point. The system worked. It worked beautifully. It worked simply. It worked cheaply. And simplicity, he was learning through uncomfortable personal revelation, was perhaps the most advanced engineering principle of all. The most sophisticated solution was not always the best solution. Sometimes the best solution was the one that solved the problem without creating new ones, that operated without constant intervention, that cost less than the GDP of a small planet. Sometimes the best solution involved admitting that civilizations 10,000 years gone had figured out perfectly adequate approaches, and perhaps advanced technology's purpose wasn't to replace those approaches, but to supplement them when truly necessary. The waterwheels kept turning, indifferent to philosophy. Gravity kept pulling, unchanged by opinion. Water kept flowing, following paths carved by human stubbornness and ancient wisdom. And across the galaxy, engineers kept learning that sometimes the oldest answers were the best ones, even if admitting it felt like failing a test they'd spent centuries studying for. Somewhere in the frontier territories, on a planet with circulation problems, a human was probably digging something and explaining that air moved when you gave it a reason to, and wasn't that interesting? The Galactic Engineering Corps would eventually arrive to study his work, write papers about aggressive simplicity versus elegant complexity, and debate whether humanity's approach represented primitive regression or advanced minimalism. Chen would not care about this debate. He'd be too busy digging the next canal, building the next wheel, installing the next absurdly simple solution to an unnecessarily complicated problem. He'd be solving the next impossible crisis with nothing but physics, persistence, and the unshakable certainty that complicated problems often had simple solutions if you were willing to get your hands dirty finding them. And if the galaxy's most educated minds wanted to debate the philosophical implications of ditches and wooden wheels, they were welcome to do so. Preferably somewhere with running water and electricity, provided by systems they'd once considered beneath them.